All right, so chapter 6 in the book, we're talking about loops or iteration, doing something over and over again. We're going to take a look at some of the basic kind of loops. Here's the chapter goals. Hopefully by the end of the chapter we'll have these figured out. To be able to program loops with while and for statements. So two different ways of doing loops. How to avoid infinite loops and off by one errors. These are really common errors in programming. If you have an infinite loop, it never ends. Your computer stops responding. It's really quite awful. We'll take a look at common algorithms that use loops. What an algorithm is a series of steps to, if you follow them, you'll come up with an answer to a question or a good solution. So we're going to learn some of those algorithms. Just like if statements, we look at in an if statement, we can nest one if statement inside of another. We can do that with loops as well. This part I like is implementing simulations, using Java to simulate the real world, like gravity and things like that. And we're going to talk about the debugger. We haven't really talked about the debugger that much, so we're going to talk about that in this chapter. So the first type of loop we're looking at is a while loop. And again, what these loops are you have a chunk of code and you want to do it over and over again. So you would use a while loop where you want to do something while the condition is true. While loops, however, just like if statements, have a conditional clause associated with it. So let's look at its structure really quick. This is a really common control structure. This is one of those that you really need to know if you're going to be a programmer. You say while, and then in parentheses, you put the condition, kind of like we did in the if statement, where we had parentheses and then we had something in the condition that evaluates the true or false. And then you can have a single statement controlled by the loop, or a whole set of a block statement that has lots of statements inside it. So let's look at what a block statement is. Most commonly, the statement is a block statement, set of statements delimited by the curly braces. Well, delimited means surrounding. Okay, so you hear the word delimited, you should think surrounding. And so what you typically do is you put the curly braces around this part here, the statement. Kind of like we do in the if statement, where we trying to show what's controlled by the if statement. We put curly braces around a series of statements. What do? I always put the curly braces, even when there's only one statement to do, in case I add one later. I don't have to include the curly braces. So if I were to rewrite this, let's see. I would do something like this. I put a curly brace there. And a closing one there. That's how I typically do it. All right, so the example that they use in the slides and in the books is this one here, where you have this bank account and you want to test when this bank account, say it's a savings account, when is that going to reach a target balance? So if I put $10,000 in the bank, $10,000 in the bank, how long will it take for me to get $20,000, let's say? How long will you have to wait, given a certain interest rate, before the balance become $20,000? So here's a little while loop that does that. You have the balance of the bank account, and while this bank account is less than the target balance, the $20,000 I'm talking about, what we do is we add 1 to years. Remember, years plus plus. Plus plus is the increment operator. That means just add 1 to that variable. So years must be an integer, and we're adding 1 to it. And then we calculate the interest, take the balance, multiply it times the rate, which is not as a percentage, or is shown as a percentage, and then you divide that by 100 to get the actual multiplier. And then take that interest and add it back into the balance. And you keep looping that way until you have figured out, or till you finally reach the target balance sheet you're looking for. So let's take a look at that loop execution. So here they're trying to show you the progression as you go through this loop, and I'll do the same. Okay, so we start out with our balance at 10,000. We're trying to get to 20,000 or so. So we're assuming that the balance is 10,000. We start out with the number of years. This is how many years have passed since you put the money in the bank. So the first thing it does is it tests the conditional expression. Is the balance less than the target balance? So right now our balance is 10,000. Our target balance is $20,000. I guess they don't show that. So $10,000 is less than $20,000. So we go into the body of the loop. Then we do the body of the loop. We add 1 to years. So now years is 1. We figure out the interest rate, or the interest on the 10,000 bucks, and it's at 5% interest. So that gives us interest of $500, and we take that $500 and add it back into the balance. And now we have $10,500. Here we go up and test the balance. Is $10,500 less than the target balance? The answer is, yeah, that's still right. So we add 1 to years. Well, we test the conditional, and then we'll keep going until we get to year 15. Now it's at year 15 where the balance is more than $20,000. So we take our balance, $2,789. Is that less than the target balance, $20,000? And the answer is it's not. So that's when you break out of the loop and you print out how many years it takes to get to $20,000. So if you can find 10,000 bucks and put it in the bank for 15 years, you can double your money. That's how long it would take. It seems like a long time. I don't know if this is true, it's anecdotally perhaps. They asked Einstein what was the greatest of man's inventions, or people's inventions, and he said compounding interest. Because here you get the interest, right, and then the next year that interest gets interest, so it's exponential. If you can leave the money there for a long time. Like, for example, if you put in 10,000 bucks in a retirement fund, when you're 21, you'll be a millionaire by the time you retire. And you don't even have to add any extra money in. It does that for you. So as soon as you can start saving for retirement, do that. I didn't do that, so I started when I was about 28. So I'm going to be eating top ramen and hot dogs when I'm in my retirement years. Or you could win the lottery. That's true. Everybody have their tickets, right? My sons are asking me, so if we won, what would we get? And I'd say, well, I'd start a company and I'd employ all my students. That's what I would do. He wants to buy an island somewhere. I think with that amount of money you could. Okay, so we have this new class called investment. It's got a balance, it's got a rate in years. So it's like the bank account, other than the fact that it has an interest rate. And also this years, but it has a balance. Here it constructs it. We put in the balance, the starting balance, and the interest rate. We'll set the years at 0. Let's go on to the next slide. Next, we put in the get balance. That's just an accessor. And then finally, how many years? Now, does it have any methods? Oh yeah, wait for balance. Okay, so you just put in the target balance. It figures out how long you're going to have to wait to get that target balance. Does it change the balance while you do it? And it does. So you have to remember that you're going to lose the initial balance because the initial balance gets overwritten. And then once you've done the calculation, you can ask the investment how many years it took. If you had a main method, say we set the initial balance at 10,000. Notice, like when you're programming that, you don't put in the comma separators when you're putting in numbers. You kind of just have to count the zeros. The compiler doesn't know how to handle that, so you got to put it just digits. The interest rate is 5. So here they make them final doubles. Those make them constants. So those aren't going to change. So initial balance is all in caps because it's a constant. We start at $10,000. The rate is 5. We create our new balance using the initial balance, or a new investment, creating our initial balance and our rate. We're trying to see how long will it take to double our money. So we call wait for balance. And then we ask it, so how many years does that take? And it says the investment is doubled after so many years. So where's the while loop in all of this? Well, it was back here in wait for balance. Just like we saw before. While balance is less than target balance, add 1 to years, figure out the interest, add the interest to the balance. Loop. Until you hit your target balance. Now, if you didn't have loops, you'd have to type that in 20 times. Or 15 times, I guess. And that's really tedious. Just take that, add 1, do it again, do it again, do it again, 15 times. I think as programmers, we get really tired of that really quickly. So, we have loops so we don't have to do that. Okay, so let's look at how to hand trace a loop. I think I have a animation here that might work. Let's try it. All right, so here's a little animation. We have our program code. I is equal to 1. We initialize s to 0. We test to see if I is less than 10. If it is, or less than or equal to 10. If it is, then we add I to s. And then we say I++. Can anyone here identify what this program is doing? This program? What will you have? What will the number represent at the end? I guess the value of s. Yeah, it's kind of hard to tell just by looking at the loop. So when you're hand tracing a loop, you usually just put I was going to do it over here on the board, but then I forgot I had this animation. But put all the variables in a table like this, and we're going to keep track of the values of these variables as we go through the code. So we'll take a step here and see. Well, we start out with I equaling 1. So we initialize I to 1. And then we initialize s to 0. And we test the loop to see if I is less than 10. Well, I is 1, and that's less than or equal to 10. So then we go to this line here, and we add 1 to s. So now s is equal to 1, and we take a step. Now we add 1 to I, so now I is equal to 2. So when you're hand tracing, you cross off the previous value and put in the new value. And then we go up to the top of the loop again. We check to see if I is less than or equal to 10. Well, right now I is 2. I is 2, and so we say, okay, is that less than or equal to 10? It is. So now we add 2 to s, right? And store that back in s. Let's see what happens to that number. So now s is equal to 3, and we add 1 to I. So is I less than 10, less than or equal to 10? The answer is yes. So we take our 3 and add it to 6, and we get 9 for the value of s. So we take a step. Oh, actually we had a 3 and we added 3 to it to get 6. And now I equals 4. And you can imagine this keeps going until keeps adding whatever I is to s. We're at 7, 8, 9, and now we're up to 10. And then we ask the question, is 10 less than or equal to 10? Answer is yes, it is equal to 10. So we still go, we keep going. So we take that 10 and we add it to 45 and we get 55. And now we set I to 11. Once I reaches 11, then this will fail, this condition will fail. So is 11 less than or equal to 10? The answer is no. So if that's the case, the loop ends and you go to the next line of code, which would be right after the curly brace. So then the question is, well, what does this loop do? Well, it looks like it sums up all the values from 1 to 10. So it's a program that adds consecutive numbers together. Now, how would this look in a flowchart? Remember, we've used flowcharts for doing the leap year thing, like over here. So anytime you ask a question, and the condition is a question or a while loop, you say, is the balance less than or equal to the target balance? If it's true, you add one of the years and then add on the interest. And keep looping. Come up on the bottom, come up to the top. The only way you can get out is when the balance finally reaches the target balance, and then off you go. Okay? So the loop keeps looping until it hits that condition. Once that condition gets changed to false, then it takes the false line and goes on later. This is a very typical control structure you're going to see. But notice we use the diamond just like we do with an if statement. This time we're having the condition control loop. So here's an example of some loops trying to figure out what it's going to print out. Here we set I to 5. We say, while I is greater than or equal to 0, we print it out. And then we subtract from I. So we're counting backwards. So your output's going to be 5, 4, 3, 2, 1. Once it gets to 0, 0 is not greater than 0, so it stops at that point. Here's another one. We set I to 5. We say while I is greater than 0, we print out I and we add to it. Well, this is called an infinite loop. We went the wrong way. See how we're adding to I? So I starts out as 5. That is greater than 0, so it does what's in the loop, and then it adds 1 to I. And now I is 6. And you see 6 is going to be greater than 0. In fact, everything's going to be greater than 0 until the whole program blows up. So this is the danger when it comes to looping, is you can get into these infinite loops. This is an infinite loop. It never ends. If you've ever, I'm sure you have, run a computer program where you're happily editing or doing whatever you want, and all of a sudden the keyboard stops responding, and the mouse stops working, and you're going, what's going on? And what's going on is it's caught in an infinite loop. It can't get out. It's just spinning its wheels at high speed. If you look at Task Manager, you look at the CPU, it's maxed out, because all it's doing is looping and it can't get out. So when you see that happening with the program, now you know what causes it. And what causes it is infinite loops, most probably. Here's another one. We start with I equal to 5. Is I greater than 5? No, it's not. So we test the condition, and it's already false. So you never even execute the body of the loop. It's like this whole thing didn't exist, because it's never going to do anything. So you get no output at all. So if that condition is false to begin with, you never execute the body of the loop. It just skips it and goes on to the next line of code. Another example, I equals 5, while I is less than 0. And we say system out that print line. Here the program's a little bit confused about it's about the loop condition. Probably what the programmer wanted to say was I is greater than 0, but put it in backwards. So again, this will have no output because 5 is not less than 0. That's false. The body of the loop never gets executed. So if you want the body of the loop to be executed at least once, you got to make sure that condition at the start is going to evaluate to true. Finally, our last example, I equals 5, while I is greater than 0, while 5 is greater than 0. We print out the value of I, and then we subtract from I. So now I is 4. This is kind of a trick one. A lot of people make this mistake is they put a semicolon at the end of the while statement. So the statement ends here. This is just a block statement that's going to be run every time. I see that a lot with if statements too. Right after the condition, they put a semicolon. And so the loop is only this line of code, and it doesn't do anything. It just loops. And it loops forever. So another infinite loop. These things will never get executed because it's in an infinite loop. It will never get out. So don't put a semicolon at the end of while statements, or the line that says while, or the line that says if. Because if you do that, the compiler thinks you're done with this loop, or you're done with this if statement, and it stops right there. And it loops forever. Doesn't execute anything further. So again, coding with loops is really essential, but it's also playing with fire. Because if you get caught in an infinite loop, then your program can't get out. So you have to guard against that constantly. So here's our while loop. We'll do a syntax card maybe next time. Right now, I just want to talk about it. So while some condition is true, you execute this statement. Okay. So the variable declared outside the loop and updated in the loop. So there's this variable called the control variable. This is the variable that controls whether or not you stay in the loop. In this case, the control variable is balance. Now, if this condition never becomes false, then it's an infinite loop and it never exits. Again, don't put a semicolon here. Be careful you're not off by 1. That's a common error. We'll look at that in a second. This variable is created each iteration of the loop, which is a little bit wasteful, but figures out what the interest is. Here it says the braces are not required if the body contains a single statement, but it's good to always use them. Okay? Why is it good to use them? Because sometimes you go back to the loop and you add another statement and you forgot to put the curly brace in. Now you have a bug in your code. So it's better, even if you only have one single line of code, always put the curly braces in, just to show that these things belong to the loop and not something after it. And then lining up these braces is a good idea because you can see the partner or the pair for this, or the closing curly brace for the opening one. So these only get executed while the condition is true. Once the condition becomes false, then it moves on to the next statement after the while loop. So whatever happens right here, that's where it jumps to once the loop terminates. So here's some self-checks. How often is the following statement of the loop executed? Well, false. Well, this is kind of silly. If it's already false, it's never going to execute the statement. Yeah, so never. What would happen if rate was set to 0 in the main method of the investment runner program? Well, if you have a 0 percentage rate, then your balance is never going to grow, which means you'll never reach the target balance. So you'll get an infinite loop, that's my guess. Yeah, so wait for balance would blow up. So you have to guard against that. If you're going to write this and you ask the user what the interest rate is and they type in something, though they type in 0, your code needs to test for that and say, hey, you put in 0%. That's going to blow up my program. I need something, a positive number that's not 0. So here's an infinite loop. You start years at 0. You want to wait until years reaches 20 or anything higher than that. So you figure out the interest rate, you add the interest to the balance, and then you go back around again. The problem here is the control variable never gets changed. Years is always going to be 0 because you didn't add 1 to years down here at the bottom. The programmer forgot to do that. So it never gets anywhere close to 20. It just stays at 0. This thing loops forever. The program's dead. So yeah, you have a program that's out of control. You need to stop it. What do you do when you need to stop a program that's out of control? Anybody know? You got a program that won't terminate, won't respond to any input. How do you close it? Yeah, you go to Task Manager, right? Bring up Task Manager, find the offending program, kill that process. Here's another one. We set years at 20. You test to see if years is greater than 0. It is. You add 1 to years. Okay? So you're going the wrong way. So you keep adding to years, and years is going up instead of down. So years is always going to be greater than 0. So again, you have an infinite loop. So it's really easy to get caught in an infinite loop. You really have to think about what you're doing when you're working with loops. Java gives you a lot of rope, but sometimes you can hang yourself really easily. This is one of those times. Another common error is called an off by one error. This happens all the time as well when you're talking about loops. Say you want to run this loop a certain number of times. For example, we'll get to the example in a second. So here's where your loop executes one too many times or one too few. This happens all the time in programming. Programmers tend to like counting at 0. This is why. Is because if they start counting at 0, these types of off by one errors don't typically manifest themselves. So here's an example. We set years to 0. We want to wait until the initial balance is doubled. So while the balance is less than that, we add 1 to the years, figure out the interest rate, and then add that interest to the balance, and we go back around. And then it says this: the investment reaches target after so many years. What could be wrong with this? Let's see what they say. I'm not seeing the problem. Okay, should years start at 0 or 1? Well, that's a tough one, right? Since we're adding 1 to years before we calculate the interest, it would seem like we want to start at 0, but you really have to sit down with it and think about it. Because the first year you're not going to have any interest, so the first year would be not 1 but 0, right? Because you haven't even done anything. You haven't really got off the mark. Let's see what they say. Another question is, should the test be less than or equal to? Well, you have to ask yourself that question. We're trying to stop this loop once it's doubled its money. So if your interest rate tends to be, or if your interest rate is 100%, say that's your interest rate. So you start out with $10,000. You add 100% interest. So now you have $20,000. And that's our target. Will this loop stop? And the answer is, well, I guess it will stop because it's not less than, right? But if it said less than or equal to, then you keep looping. So you gotta ask these questions. What should this number be? What should this relational operator be? Those are tough questions, and you have to do it by hand. So trace the loop and see if you get the number of iterations you're expecting. So evidently this is correct. That's why I couldn't find a problem with it. It's actually accurate. Okay, so these are tips to avoid this off by one problem. Say you have an initial balance of $100. You set the interest rate at 50%. After year 1, you get $150. After year 2, you get $225. So the investment doubled after 2 years. The loop is executed 2 times, incrementing year each time. Therefore, years must start at 0, not 1. Find a bank that'll give you 50% interest. Let me know, because I want to put my money there. What are the banks giving out as interest right now? Anybody know? Yeah, it's terrible. It's like 1.1% or something awful like that. It's like free money to them. I used to write internet banking software, and so I know how banks do their accounting, and they really like it when they don't have to pay a lot of interest for your money. I like it when the banks charge you a fee for storing your money at their bank. See, our interest rate is 100%. Like I said in my example, say you start at $100. The target balance is $200. Loop should stop once you reach that. So instead of saying less than or equal to, you would say less than. So think about the relational operator that drives your condition. Think about what the initial value is for the answer that you're trying to get to. And this is really common. Programmers tend to code stuff and it goes, hey, it loops, it's done, woo. But you haven't thought about it. You just typed in the loop and, hey, it spits out numbers. That must be true. Now, you can't do that with loops. Loops, you really have to understand what you're saying. If you don't understand what you're saying, you're going to be caught in infinite loops or loops that never execute. So don't just type in the code from the book. See if you can understand how the loop works. Without a clear understanding of loops, your tenure as a software engineer or computer programmer will not last very long. We had this person where I used to work where he would ask for help. And so he did this to everybody, but he asked for help. And so I helped him out. And then because of the way he coded it, the program wouldn't work. He says, well, Dan told me to do it this way. So he blames the problem on me because he didn't think through his loop. And he did that with everybody. You try to help him out, and once it doesn't work, he would blame you for his problems. How much longer do you think he got help? Nobody helped him after the first couple times. Why don't you help me out? Well, why? Because you always blame the person that helps you. We're not going to help you anymore. You're going to have to do it on your own. So he lasted about 2 weeks. Then it became clear that he didn't like to think through his problems, and he wanted other people to do the thinking for him. And pretty soon we got tired of it, so we didn't. I'm usually a very helpful person, so it's hard for me not to help, but in that situation,